right, so this is 7.5 parametric equations, day 1. So first off, we have some fill-in-the-blank vocabulary here. It says blank equations define relations as a set of equations. And this is parametric. So parametric equations define relations as sets of equations. A graph is said to be parameterized if the set of coordinates x, y on the graph are represented as functions of the variable, usually t. Parametric equations are usually used to represent the motion of an object at any given time t. So parameterized. From one input called the parameter, we can find both coordinate points with our parametric equations. All right, so here is our first example. And it says, given the parametric equations, x of t equals 4 minus 2t and y of t equals 5 plus 3t, use a table of values to plot the graph over an interval of -3 to 2 for t values in between -3 to 2, including both, and then also make sure you're including direction. All right, so first thing we're going to do is we are going to take these t values and put them in our table, and that's -3 to 2, including -3. I'm just going to use the integers instead of decimals. You could use decimals, but I'm not going to. So -3, -2, -1, 0, 1, and 2. So now what we're going to do is we're going to plug each of these t values into each of these given equations. So to get my x values, I'll plug them into this equation. So I'm going to start by plugging in -3. 4 minus 2 times -3. -2 times -3 is 6, and then 4 and 6 is 10. Now I'm going to plug in -2. If I plug in -2, I get 4 plus 2, which is 8. Now I'm going to plug in -1, and I get 6. You should be noticing that there is a pattern in these values right now. They're decreasing by 2, and that's because there is a slope of -2. So if you want to get your next 3 terms, instead of plugging in 0, 1, and 2, you could just keep decreasing by 2. 4, 2, 0. Okay, so now we are going to do the same thing, and we are going to plug in -3 into our y equation. So we're going to plug in it into -3, -2, -1 into that equation. Okay, so we'll start by plugging in -3. Remember, we're plugging in this t value, not that x value that's next to it. So plugging in -3, I get 5 plus -9, which is -4. Plug in -2, and I get 5 plus -6, which is -1. And then once again, even by getting that first one, if you notice right here, the slope of this line, like if you think about it as a line, it's y equals 3x plus 5. The slope is 3, so it's going to be increasing by 3. So you could just keep adding 3 if you wanted to, or you can plug in -1, 0, 1, and 2. I'm going to keep adding 3. So 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. All right, so now what you have is you have these points right here. And if you're like, what points? These x, y ordered pair points. So you have 1, 2, 3, 4, 5, 6 points that you can graph. So you're going to start with the first ordered pair, 10, -4. And you're going to graph 10, -4. That's your first point. All right, so now you're going to graph 8, -1. Second point, 6, 2. Third point, 4, 5. 2, 8, and 0, 11. Now you're going to connect these points, and it's only on the interval of -3 to 2, so you're not putting arrows on the end and saying it's going on forever. It goes from -3 to 2, okay? The t values from -3 to 2. And now we also have to show direction. So you have to go back to the point you first graphed, which was 10, -4, and then say I went in this direction to go to my next point, and then I went in this direction, this direction, this direction, and this direction. So there's me showing direction, showing you which one you got first all the way to which one you got last. All right, next it says eliminate the parameter t to find an explicit or rectangular equation of the line. All right, so we want to eliminate the parameter t when we have these two equations right here. Well, wrong thing. These two equations right here. Okay, so I'm going to start by taking the first equation, which I'm going to write x equals instead of x of t equals. I'm just going to write x equals 4 minus 2t. And then I have my second equation, which is y equals 5 plus 3t. So what I'm going to do is I'm going to try to eliminate t from the equation by solving this equation for t and then plugging it into the second equation in the place of t. So let's solve this equation for t. First thing I'm going to do is subtract 4 from both sides. X minus 4 equals negative 2t. And then divide both sides by negative 2. So I have t equals x minus 4 over negative 2. All right, so now I'm going to take my other equation, which was y equals 5 plus 3 times t, and instead of writing t, I'm going to substitute this in for the t value, okay? So that is going to be x minus 4 over negative 2. Now we have to clean this up. So we have y equals 5. All right, so now if you look what you're doing, you're distributing your 3, and then you're going to divide by negative 2. So I'm going to distribute my 3, and then I'll divide by negative 2. So 3 times x is 3x, divided by negative 2 is negative 3 halves x. Multiply by 3, that's negative 12. Divide by negative 2, that's positive 6. Now I can clean this up a little bit more by combining like terms. So I have y equals negative 3 halves x plus 11. And that's the equation of the line. If you look at this equation, you do see a y-intercept of 11 right here. And then if you go down 3, left 2, you do get that next point there. So how could we have found the slope of the line from the parametric equation? So how could I have found negative 3 halves using these two highlighted equations in orange here? So look for negative 3 halves. If you look, there's a 3 right here as the slope of that line. And then negative 2 right here, the slope of that line, negative 3 halves. So we can get the slope of the line using the coefficients of t. All right, those were the coefficients on t. This one was 3, and this one was negative 2. This is from y, this is from x, so make sure you're doing y over x. So we could have done, once again, 3 over negative 2, which is negative 3 halves. All right, keeping that in mind, it says write a set of parametric equations of the line that passes through the point 6, negative 2 and has a slope of 4/3. So we want to write our parametric equations instead. So we want x of t equals and y of t equals. So we already said the slope, the 4/3, we can get from the slope on the equation for y and the slope on the equation for x. So the slope on y is going to be 4 and the slope on equation x is going to be 3. And then also remember this is a point x comma y. So if we go back to our equation that we graphed from before with all this writing that I have on it, let me erase this all real quick. You can see that the slope is 3 over negative 2. And then also you can see that there is a point x, which is 4, comma y, which is 5, that is on the line. So if you look, 4, 5 is on the line. It's listed right here. And it's graphed right here. So that's what we could do to write an equation. There's many, many, many answers that are possible, but I think this is the easiest way to do it. So take the x value right here, which is 6, and then you're going to write your slope with your variable. So for the x, it's 3, so it's plus 3, and then remember your input is t. For my next equation, I have negative 2 plus, and if you look, your slope for this is y, or sorry, your slope for y is 4, so 4, and then your variable is t. Once again, this is just one possible answer. All right, next, write in a parametric equation of a line that has a rectangular equation of y equals negative 4/5 x minus 3. So here I see the slope, right, negative 4/5. So I can say, like, I can put this as the slope of y and this is the slope of x. And then also I need a point on the line, just like the one above. So I'm going to use the y-intercept as 0, -3 as my point. So I'll say x of t is equal to, I need the x value in the point, which is 0. Could write 0 if I want, like this. And then I'm going to do plus my slope t. So for x, it's a 4, or you can use -4. The negative has to go with something. So I'm going to put it with the x slope. So I'm going to do minus 4t. Once again, you don't need the 0 here. You can just have x of t equals -4t. And I'll say y of t is equal to, I have the y value of -3, and then I have the slope of 5. Notice I already used the negative, so I'm going to put plus 5t. So another possible answer is making that positive and making this negative right here. Like, oop, that's not making it negative, making it negative like that. So that's another possible answer, but I'll stick with the one I started with. Okay, next it says eliminate the parameter to find an explicit equation of the following line. So I'm going to show you 2 ways to do this, okay? I'll show you the easiest way second, and then if we want, we can do the second equation in just the easy way, or it's whatever you would rather do. You get a pick. So if you want to eliminate the t value in the equation, what you can do is you can take the first equation and solve for t. If you look, this is root t, and this also has a root t. So what I can do is I can solve the first equation for root t and then substitute the root t for whatever I get. That's what I'm going to do. So this equation is x equals 2 minus 3 root t. And I'm going to solve this equation for root t. So I'm going to subtract 2 from both sides. And then I'm going to divide both sides by -3. So I have root t is the same thing as x minus 2 over -3. So now what I can do is that I can replace any root t with x minus 2 over -3, which is right here. And that's what I'm going to do. So I'm going to do y equals 1 plus 4 times, and then x minus 2 all over -3. Clean it up. Y equals 1. So I'm going to multiply by 4 and then divide by -3. So 4x divided by -3 is minus 4/3 x. 4 times -2 is -8. Divided by -3 is positive 8/3. Clean this up by combining 1 and 8/3. Remember, 1 is just 3 over 3. So I have y equals -4/3 x plus 11/3. So that's one way of doing it, but there is an easier way. You can use the slope and a point. So I can say, I'm just go like this. I can say the slope of the line is going to be 4 over -3. So -4/3. And I need a point. So I can say, all right, where's there a point? X comma y, 2 comma 1. And then I can say y minus y1, which is 1, equals m, -4/3 times x minus x1, which is 2. And you can leave your answer like that because that's point slope form and it's a line. Didn't say it had to be in a certain form. All right, let's go ahead and do this one both ways again. And once again, you can choose either way that you want in the future. This is x plus 7. No, it's not. It's x equals 7 plus t cubed. To solve for t cubed, because notice I just have to get t cubed by itself because I can replace that t cubed with it. So subtract 7 from both sides, and I have t cubed is equal to x minus 7. So now I can replace t cubed here with an x minus 7. So I have y equals -2 minus 3 times x minus 7. Y equals -2 minus 3x plus 21. Y equals -3x plus 19. So that's one answer that you could have. Or you can do it the same way that we did the other one. You can say, okay, what's my slope? My slope is -3 over 1, -3. What's a point on the line? XY, 7, -2. So y minus y1, y plus 2 equals m, -3 times x minus 7. And you can leave your answer like that. Notice if you distribute the -3, you get minus 3x plus 21, and then subtract 2 from both sides, you get 19. These are equivalent answers, and so are the other two. Okay, that was lines. Now we're going to look at our next parametric curve, and that is a parabola. So it says plot the parametric curve defined by, and it gives you two equations over the interval. So if you look at these two equations, you have one that is a square and that has a square in it. It's a quadratic, and then one that's linear, right? And our ones that we were doing before, they are the same. So this was a square root and a square root, a cube and a cube, linear and a linear. So that's going to give you lines. When you have a square and a line, or linear, you're going to get a parabola. So let's see what it looks like. It tells us the interval that we're graphing it on. It says from -2 to 2, including both. So -2, -1, 0, 1, 2. Let's plug -2 into the first equation. So we're going to plug it in here. -2 squared is 4. 4 times 2 is 8. 8 plus -1 is 7. Make sure you're doing order of operations. Next one, plugging in -1. -1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. Plug in 0. 0 squared is 0. Times 2 is 0. Plus 1 is -1. Plug in 1. 1 squared is 1. Times 2 is 2. Plus -1 is 1. Plug in 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. Notice that just like when we graph a parabola, because this is a quadratic right here, we get that pattern, that symmetric pattern there. All right, now I'm going to plug in -2 into my next equation for t. 4 times -2 is -8, minus 3 is -11. Since this is linear, I can look at the slope, which is 4, and just keep adding 4, or I can plug in 1 and say 4 times 1, or sorry, plug in -1. 4 times -1 is -4, minus 3 is -7. But if you look, it just increased by 4. Increased by 4 is 3, increased by 4 is 1, increased by 4 is 5. That only works for a line. Remember that. All right, now if you look at your ordered pairs, you have 1, 2, 3, 4, 5 points to graph. We're going to start at 7, -11, right here. And then we have 1, -7, -1, -3, 1, 1, and 7, 5. We're going to go ahead and make our parabola's. Notice it's a parabola that's facing to the right. And I'm actually connecting them in the order that I got them. Well, that doesn't look very good. I'm going to connect them in the order that I made them and then make sure I show the direction. So I started at the one on the bottom and then I moved this way. And there is my parabola. All right, next it says find the values of the parameter t at which the x-coordinate, x equals -5. Find the y-coordinate at those times. Well, I took this out of the notes and I just forgot to put it in Schoology before I made my screencast, so we're actually skipping that one. All you do is set x equal to 5 and solve for t and then plug it back into y, but we're going to skip that one. All right, next one says eliminate the parameter to find the rectangular equation for the curve in terms of x and y. So we're going to take our first equation, x equals -1 plus 2t squared. What we're going to do is we're going to have to solve it for t. Unfortunately, we can't solve for t squared. We would have to solve it for t and then plug it into our next equation. So since this is the square root, and if you look at the next one, it does not have a square root in it, it's going to be easier to solve that equation for t and then plug it into the first one. So that's what I'm going to do instead. So I'm going to say, okay, well, instead, I'm going to do y equals -3 plus 4t. And I'm going to solve this equation for t and plug that into the other equation. So add 3 to both sides. I have y plus 3 is equal to 4t. And then divide both sides by 4. And I get t equals y plus 3 over 4. All right, now I'm going to write down that other equation that I ended up erasing, which was x equals -1 plus 2t squared. Instead of writing t, I'm going to replace t with this y plus 3 over 4. All right, so now I want to get this to actually look like a parabola because this is not our standard form of a parabola. So what I'm going to do is I'm going to square both my numerator and my denominator. So I have x equals -1 plus 2 times, and then I square my numerator, y plus 3 squared, square my denominator, which is 4 squared, which I'm just going to leave as 16. All right, so now I'm going to clean up the 2 in front. I have a 2 in front, which is multiplication, and divided by 16. So instead of saying times 2 divided by 16, that can simplify to an eighth. So I'm going to keep a fraction or a coefficient of 1/8 in front of that, because it's going to look more like my parabola. Getting close, right? The only other thing I have to do is that the -1 shouldn't be in front, right? So I'm going to move the -1 over here. So I have x equals 1/8 y plus 3 quantity squared minus 1. So if you look, this is a parabola facing to the right. Well, that's not very nice. Facing to the right with the vertex of -1, -3, right? And if you look, that's what we got. Vertex of -1, -3 facing to the right. What kind of conic section is this? It's a parabola. What information do we lose just by looking at this right here? We lose these arrows, right? We don't know which the first point is and what the last point is. So we lose the direction. And I don't mean direction facing to the right. I mean those arrows that are showing me which one I got first to which point I got last. Okay. So last but not least, what we're going to do here is we're going to go through our equations. We're going to graph A and A from 6 and 7 together, and then the B's are going to be your homework, so I'm not going to do those. All right, so it says, remember that a horizontal parabola is written in the form x equals 1/4p times y minus k squared plus h. The parametric equation for a horizontal parabola are given by, so here's what a horizontal parabola looks like in parametrics. If it's x equals, like this, your x is going to be your squared function. So this is going to have your square in it. So this is how you're going to get it. It's going to be the h value of the vertex, and then plus the p value, this p value here, times t squared. It's going to be your quadratic. Your quadratic, so that t squared is on the x because this is an x equals. I shouldn't say on the x, it's in the x equation. That's how I remember it. Then you have the k value of the vertex plus 2 times the p value, t. Vertical equation of a parabola is similar. So we have y equals 1/4p times x minus h squared plus k. So for the parametric, the y is going to have the quadratic on it. So it's going to be, this is still h, this is still k, because it's still hk, right? But this is going to be plus pt squared. The quadratic is going to be with the y if it's y equals, and then this will be plus 2pt. Okay. So it says convert the parabolas from rectangular to parametric form. Then identify the vertex, the opening direction. Finally, use the parametrics to plot the graph over the interval of -2 to 2. Okay, so we need to get the parametric form of the graph. All right, so this is x equals. So we have x of t equals, and we need y of t equals. If you look at what you need for this, you need your vertex, hk, and then you need the p-value, right? And the p-value goes there and there. Okay, so let's go ahead and get those two things, hk and the p-value. So this is a parabola facing to the right. The vertex is hk, where this is h and this is k. So I'm going to write it off to the side. I'm going to say the vertex is 3, 2. And then the p-value, I have 1/12 is equal to 1/4p. Solve that equation for p. You can cross multiply and say 4p equals 12, p equals 3, or you can just look at it and say p is 3. All right, so now I'm ready to write my equation for my parametric equation for x. Since this is x equals, this is going to be my quadratic right here. It's the h value, which is 3. I can even throw the k value right here too, so I don't forget. And then this is plus pt squared. So p was 3, so this is 3t squared. This, I already have the k value plus, and then it's 2 times the p value, which is 6t. Okay? When you are doing yours later, you're going to still do x of t equals and y of t equals. And you're going to still put h here and k here, but then you're going to put plus pt squared here and plus 2pt here. Okay, let's go back to the one that we're doing though. All right, so now we got our parametric equation. It says identify the vertex and the opening direction. And finally use parametrics to plot the graph over -2 to 2. So the vertex we already did right here. Done. I have the eraser on. Vertex right there. So we'll say vertex. The opening direction, this is facing to the right because it's x equals a positive number. And now we're going to graph it using the parametric equation here. So I'm going to copy this so that it's right in my face here. I'm going to paste it down here. Now I'm going to get my t-values. T-values are written right here, -2 to 2. So I'm plugging in t-values here, -2, -1, 0, 1, 2. And I'm getting x and y values, and then I'm going to plot those. All right, plugging in -2 into the first equation right here. -2 squared is 4. 4 times 3 is 12, plus 3 is 15. Remember, this is a quadratic right here, not linear, so I can't just keep adding 3. I have to keep plugging it in. It should, however, be symmetric. Plug in -1 now. -1 squared is 1 times 3 is 3 plus 3 is 6. Plug in 0, I get 3. Plug in 1, I get 6. And plug in 2, I get 15. So it is symmetric for that quadratic right there. All right, now I'm going to plug in -2 right here. 6 times -2 is -12, plus 2 is -10. This is linear, so I can just keep adding 6, which I'm going to do. -4, 2, 8, 14. Now I'm going to graph my 5 points. 1, 2, 3, 4, 5. Do you have to put parentheses and commas around it? No, it just helps my brain not use these. Okay. All right, so I have 15, -10. 15 is not on the graph paper, but just by 1. That doesn't happen for any of yours. That's why I want to do this one with you. 6, -4. 3, 2. 6, 8. And finally, 15, 14. 15, once again, not on the graph paper. That's okay. And then now I'm going to make my parabola facing to the right like we said it would be facing. Put it through my points here. That's good. And show the direction. So I started at that one on the bottom, and I went in this direction. All right, so this next problem here is homework. It's labeled homework on your worksheet. Once again, I forgot to put the updated version for myself in Schoology. All right, last one, 7A. First, identify the vertex in the opening direction. Then use the parameters to plot the graph over the interval of -2 to 2. Finally, check your answer, converting the parabola from parametric to rectangular form. Okay, so we need the vertex first. That's what it said us to do. First, identify the vertex and opening direction. All right, so our vertex, remember, this is H, and then we need K. But if you look, this is your T squared right here. So this is 0 plus 3T squared. So this is our K value. So our vertex, we know, is 1, 0. All right, opening direction is based on whether the p-value is positive or negative. If you look, this is a positive pt squared, so that's 3. Or if you look here, this is 2p, which is 2 times positive 3. So we know that p is 3, so it's a positive number. So this has to be facing either up or to the right. If you look, this is y equals the square, so it's up. If it was x equals the square over here, it'd be to the right. Okay, so this is upward facing. All right, now what did it want me to do next? It says use parametrics to plot the graph over that. Finally, check your answer by converting. Okay, so now I'm going to plot my graph. All right, so I'm plugging in -2 to 2. So these are my t values, x values, y values. -2 to 2. -2, -1, 0, 1, 2. And I need to plug -2 into this equation right here. So sorry for the zoomed outness, but I need to be able to see it. All right, so plugging in -2, 6 times -2 is -12, plus 1 is -11. That's a linear equation, so I can keep just adding 6 if I'd like, which I'm going to do. Negative 11 plus 6 is negative 5, plus 6 is 1, plus 6 is 7, plus 6 is 13. If you want, you could always check the last one. Plug in 2, you get 12 plus 1, which is 13, just to make sure you didn't make a mistake. Now plug in negative 2 into the second equation. Negative 2 squared is 4 times 3, which is 12. Negative 1 squared is 1 times 3, which is 3. Plug in 0, I get 0. And then I should get 3 and 12 again. Plug in 1, I get 3. Plug in 2, I do get 12. Now I'm going to graph my 5 points. I have negative 11, 12. So that's where I started. Negative 5, 3. 1, 0. 7, 3. And 13, 12. Okay. Connect those points and make sure you show the direction. So I started at that point on the far left, and I went in this direction. There is my parabola. Last thing it asked me to do is finally check your answer by converting the parabolas into parametric, from parametric to rectangular form. Okay, so this is y, and this is my square, so I know it's y equals 1 over 4 times p, that's 1/12, right? 4 times 3 is 12. And then x minus h squared, which is 1, plus k, which is plus 0. So this is my equation, and now I can look at the parabola. Look at that, that was kind of a parabola. Oh, I did it again. Just let it go. There we go. And then look to make sure that that's correct. So if you look 1, 0, that works. And then the p-value is 1/4, which is not a good way to check, but I can plug in another number next, and I say plug in 2, and I get 1/12, but that's hard to check too. So let's see if I plug in 7, if I get 3. Plugging in 7. 7 minus 1 is 6. 6 squared is 36. 36 divided by 12 is 3. So it is correct. All right, so this other one here is homework for you. Go ahead and do those 2 problems.